All right, we'll see how far we can get today in 20 minutes or whatever we have. This is the SLO review packet. The test on this first part will be Monday to determine the approximate length of an arc. What is that called? Does anyone remember the variable we use for length of an arc? Yes, S equals R theta. And that is on the reference sheet. You will have this reference sheet for the test, okay? It's right here. But, there we go, I heard it already. It doesn't work until theta's in radians. So somebody's going to type in 80 and just write it down and get it wrong. What do you have to do to change? Okay, we need degrees to go away and radians to, could you do 2 pi? If you put 2 pi over 360, it's the same thing. Pi radians is 180 degrees. This is just reduced. You can get a big ugly decimal. You can just cross this out and be done, right? Because now you have radians. How do you find arc length? Once you have theta in radians, you multiply it by the radius, which is 11 centimeters. And what happens to that magical radians label? This goes away, and we end up with centimeters. It says rounded to the nearest tenth. So that means, guys, please type it in. 80 times pi divided by 180 is 0.1396, blah, 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 times 11. I got 15.4. Did anybody else get 15.4? I'm a little nervous. What if you had rounded that to 1.4 and then multiplied by 11? You'd still get 15.4, so that's good. All right. Okay, question asked. Do you have to be in radians mode? Okay, I think I talked about this with those of you who were here yesterday. Did I talk about it in this class? The only time it matters, guys, when does it matter when you're in radians or degrees? If you're pushing sine, cosine, or tangent, it's the only time. Otherwise, it doesn't matter what you're, okay? Sine, cosine, tangent, which we did not push on this question, so it does not matter. All right, find the linear velocity of a gear that is turning. What does this mean? Okay, revolutions or rotations, I don't care which one you use, per minute. And has a radius of 5 centimeters, and we want a linear velocity. Okay, so I flip to my reference sheet. It says V is linear velocity, and it says to get a linear velocity, I should take angular velocity times radius. Okay, but angular velocity means it has to be in radians. So how do I change this first to get rid of revolutions and change it to radians? 2 pi radians is 1 revolution. So cross the revolutions out. Now I have radians per minute. So all of this together is an angular velocity. And then I'm supposed to multiply it by a radius, which would be 5 centimeters. Now what's going to go away? Radians, but I'm still going to have what? Centimeters per minute. Is that okay? It didn't tell us, right? Didn't say what we had to have. Okay, so centimeters per minute is fine, but it doesn't want to the nearest tenth. So it's 4,000 times 2 pi times 5 centimeters. 125,663.7. That was a giant number. 125. Tell me one more time. 6. Thank you. All right. That would have been a really nice question if it said, like, change it to meters per hour or kilometers per hour, and you'd had a more reasonable, smaller number. But I'm thinking you like it the way it is, yes? Because you don't have to convert anything or know any conversions. Okay. Number 3, let theta be an angle in standard position with the point. Okay, here's an X, here's a Y. What quadrant am I in? -5 up 12, okay? Find the cosecant. Yeah, I can use my reference sheet if I need to. Somewhere it says cosecant on the reference sheet. What is cosecant? Okay, and what is sine? Sine is opposite over hypotenuse, so cosecant would be hypotenuse over opposite. Do we know the hypotenuse? 12 squared plus, someone is, every time I still have people who do this as a negative without the parentheses. I just want to cry. Okay, the hypotenuse should be the longest side. It won't be if you don't put parentheses around that negative, or if you could just skip the negative and put it in as a 5. Okay, Pythagorean theorem gives us 13. So 13 over opposite would be 12. What's another definition that should help us here? The sine is y over r. That sound familiar to anybody? You're supposed to know those. R over y. Y was 12 up here, right? Okay. Find the exact value of, what is this? This is just go to the unit circle, yes? Okay. 5 pi over 3. 5 pi over 3. 1/2 and negative square root of 3 over 2. Whoops. So the ordered pair is 1/2 negative square root of 3 over 2. How do I do cotangent? X over y. But what did we talk about? These denominators they're going to cancel out. So we're going to end up with 1 over negative square root of 3 or negative root 3 over 3. Question so far? Are we acing all these? Okay. Oh, this is where every time we lose somebody because they don't know what that symbol is. Greater than 0, positive, right? Cosine is X or Y? X. Where's the X positive? Over here, yes? Okay. The sine is negative. Sine is related to Y. So we're down here. Or you could do all students take calculus. The cosine is positive down here. The sine is negative. Okay? How am I going to label that triangle? Opposite is -7. Hypotenuse is 25. Okay? It says quadrant of the angle. Please tell me you know your quadrants. That is quadrant 4. How do you know which quadrant? And it is an explain question. If you don't write some kind of an explanation, you lose points, okay? Cosine is X, so it's positive in quadrants 1 and 4. Sine is Y, so it is negative in quadrants 3 and 4. So we must be in quadrant 4, right? Could you use a bunch of words instead of that? I just was writing something. You can put it however you want. Pretty much you fill it out and what you wrote makes sense and I'll be happy, okay? Now it does ask for the tangent. How do we find the tangent? 25 squared minus 7 squared square rooted The 20. And so tangent is opposite over adjacent. Is that 24 positive or negative? Because I went to the right, yes? This is where, if we had wound up in quadrant 3, everybody just puts down the 24 and they forget it goes to the left, it's negative. Okay, so just be careful on that one. Because remember, these aren't the exact questions, right? Would be in a different quadrant on the actual SLO. All right. Write this trig equation. Oh, solve this trig equation. Okay. Those of us who were here yesterday did this. Did anybody remember? Yes, take out a cosine. What will it say then? So we are looking for where the cosine of x is 4. Okay. And it says all exact solutions in radians from negative infinity to infinity. What does that mean my answers are going to need? Okay, I don't know how many am I going to need. And I'm grading this, so you can write these however you want, as short or as long as you want to write them. But the cosine is 0. Well, if you need to, go back here. Where's the cosine 0? 3 pi over 2 and 2 pi over 2. Is there a shorter way to write that? You don't have to. Yes. Andrew's suggestion was pi over 2 plus or minus pi n because they're straight across from each other. Anybody remember, because it's cosine, we could have written plus or minus pi over 2? If you went up 90 or down 90, right? Plus or minus 2 pi n. Either of those are the same as combining those. What about cosine is 1/2? Cosine is 1/2. Pi over 3 and 5 pi over 3, which you could list pi over 3, 5 pi over 3, or you could have said plus or minus pi over 3, plus or minus 2 pi n. Okay, so there's a shorter version, but this will work for me. Questions? All right, let's see if we can make it at least to 10 here, okay? Identify the number that changes the period and state the new period. What is the funky number out of this mess that's going to affect the period? This whole thing, right? 3 pi over 5. And what is the relationship that we have to have memorized? 2 pi divided by b is the new period. So, how do I do that? 2 pi divided by 3 pi over 5. What happens when you divide? So this becomes 2 pi times 5 over 3 pi. Pi's will cancel out, and what do we have? 2 times 5 divided by 3 is 10/3. I don't know if it's that ugly on the quiz, but or the SLO could be, right? Because you don't have to graph it. You don't have to do anything with it. Show me that you know fractions. Which is scary for some of you. Okay. Identify the phase shift from a regular cosine. What's happened? Yes, and it's in factored form nicely for us, right? So the phase shift of pi over 6 units to the right, even though it's minus. All right, how are we going to graph this one? Amplitude is 4. Period is 2 pi divided by this b of 2, right? So we get pi. And it's a cosine, so what does that mean? Start the max, 1, 2, 3, 4. And it finishes by is that graph paper working for you? Oh! I don't know what happened there. All right. Yeah, I can't draw it no matter what I do. Okay. It says label the points A, B, C, D at label 5 points within 1 period. A, B, C, D, E. Anybody help me with the ordered pairs? 0, 4. What should we be counting by? If our period was divided by 4, we'd have the quarter points are every, so this should be pi over 4, 2 pi over 4, 3 pi over 4, and 4 pi over 4, which makes them pi over 4, 0, pi over 2 when we reduce, negative 4, 3 pi over 4, 0, and pi 4. The one you have to graph and give the ordered pairs for has 2 things going on, okay? It does not have a phase shift and a vertical shift and a period change and an amplitude change, okay? 2 things. All right, can we get this last one in here? Where would you start? Oh, it says we have to call this a sine graph? Okay. I would find the midline first. If it goes from 2 to negative 4, where's the midline at? Negative 1, right? So the vertical shift is down 1. What is the amplitude? How far above and below that is it going? 3. Now we got to figure out the sine shift, or the sine graph business. I'm going to start here, I think. Will that work as a sine graph? What would that be? Right pi over 4. And it finishes where? Yes, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4 here, 5 pi over 4. If it finishes, if it went to the right pi over 4 all the way to 5 pi over 4, how long was that? Pi. Which makes B 2 pi over 2 over pi, or 2. So we'd have 3 sine 2 x minus pi over 4 minus 1. Right. I have an extra practice on this tomorrow anyway, okay? So we will pick up there.